And next we have to see a relationship between intensity and wavelength, clear, at a given temperature. So exact frequency distribution of the emitted radiations from a black body depends only on its temperature, clear, मतलब किस पर्टिकुलर फ्रीकुएंसी की जी रेडिएशन है वो एमिट होनी है, ठीक है, डायरैक्टली कि उपर डिपेंडेंट है कि कितना आप जो टैंपरेचर है वो उपर ब्लैक बॉडी में की है हीट कर रहे हैं, ठीक है. सो एट अ गिवन टेंपरेचर इंटेंसिटी ऑफ रेडिएशन एमिटेड इंक्रीजेज विद डिक्रीज ऑफ वेवलेंथ and reaches a maximum value at a given wavelength. As you can see from here, initially at a given temperature, as the wavelength is shorter, and again it will going to show a certain rise in its intensity, clear. This is the intensity variation with respect to the wavelength at a fixed T1 temperature. Here you can see once it will going to reaches a maximum value at a given wavelength lambda 1, that its value will be 1500 nanometer, clear, and reaches a maximum value and then starts decreasing with further decrease of the wavelength, clear. As you can see from here, initially it will going to show us some increase. After reaching to the highest point, again it will start going to decrease again with increase in its wavelength, clear. And same for T2 temperature, as we have increased the temperature, the intensity of the emitted radiation will going to increase, which will result in higher frequency, clear. That's why we are saying that frequency of emitted radiation is directly related with the temperature on which we are heating the black body. So above experimental results cannot be explained satisfactorily on the basis of the wave theory of light. Planck suggested that atoms and molecules could emit energy only in discrete units, clear. According to Planck, he suggested that energy is present in the form of the small packets or in the form of the discrete units, clear. That's why if overall energy is same for this emitted radiation, then there should be same kind of behavior, means the variation of intensity and wavelength on at a given temperature will going to show a same trend. But here you can see there is variations are occurring. Firstly it will going to increase and again there is a fall, clear. So this can be explained only if we are considering that energy of each particles that are existing in electromagnetic radiations will going to have quantized kind of energy, clear, means the discrete units of energies are available for each particle that will going to behave in a different manner at a same temperature. So the energy of a quantum of radiation is proportional to its frequency nu and is expressed by equation E is equals to h into nu, where h we can say is a Planck's constant and proportionality constant. H is known as Planck's constant and has the value 6.626 into 10 raised to power minus 34 joule seconds, clear. So this is the theory that is proposed by the Planck. So with this theory, Planck was able to explain the distribution of intensity in the radiation from the black body as a function of frequency or wavelength at different temperatures, clear. As you can see that here energy is directly proportional to its frequency. So we can say that intensity of the radiation from the black body is a function of its frequency or wavelength, means going to vary with frequency or wavelength at different temperatures. So with this our particle nature of electromagnetic radiations we have completed with the help of the Planck's quantum theory. You have seen that we are able to explain the particle nature of electromagnetic radiations, that how waves can be show a particle like character. That can be explained only if we are considering that energy for each particle will going to have a different values, means energy will going to exist in a discrete units, and relation between energy and frequency you can see from here. So if any doubt regarding this topic, you can ask me question regarding this topic anytime.